So as we approach the more challenging problems, 4 and 5, we'll start to notice a few differences. We are now dealing with exponents, but not to worry, it still should be fine. You just have to apply the previous rules we learned before and look at the problem in a different perspective. So what we have here is 2v squared times p minus a times t times r squared equals to hl. It's the same concept. What we did on number 3 for treating this as a whole, we're going to do here for number 4. So don't let the exponents scare you. So here we want to treat 2 times v squared times p as a whole. And we want to move it over to this side so that then we have this whole by itself. So now, in order to do this, always remember this is what we're trying to move. So we have 2v squared p minus atr squared is equal to hl. So what we did before, we're going to subtract this as a whole. So minus 2v squared p minus 2v squared p. This whole thing cancels out, so now you're starting to see how easy it's going to be. So we're left with negative a t r squared is equal to h l minus 2v squared p. So this is now becoming a lot easier. I'm just going to erase this part after we have simplified it. And now what we want to do is, again, get t by itself. And we can see that negative a times t times r squared, that's the whole. But we want to get it by itself. So now what we did before, we just have to divide negative a and r squared to this as a whole. So we're going to divide it, negative a times r squared. Because here it's being multiplied, so now you can divide it. And we apply this to the other side. Negative a r squared. This cancels out. So after we've canceled it out, as you can see here, we just have to rewrite it. So now t is now by itself will equal to hl minus 2v squared p divided by negative a r squared. And that would be the final answer for 4. As you can see, it wasn't that challenging, even with the exponents. So now let's move on to number 5. For number 5, you can see that you have exponents and a denominator. But yet again, what we've learned in these past 4 problems will just be combined in this final problem, and everything should just be a lot easier. So as you can see, we have wp to the 3rd power minus r times t times s to the 2nd power over a times x is equal to w. Let this not be a problem. We'll just apply the same concept for what we did for number 2. When we have the denominator, we always want to multiply it to bring it to the other side. So let's just bring this up here. And now we have wp to the 3rd minus rts squared over a times x. So as we did in question number 2, we multiply the denominator equal to w times a times x. We multiply the denominator in order for it to cancel out and bring it over to this side. So the one is basically just another way to say wp to the 3rd minus rts squared. So it doesn't really matter. wp now to the 3rd minus rts squared is equal to wax. Always pretend that there's an imaginary multiplication sign, because this in terms just means w times a times x. So now we're starting to see that the problem has no denominator, and it's becoming easier for us to work with. So, as we did last time, let's treat this as a whole and try to move it to this side in order to get t by itself. And that would just be minus wp to the third minus wp to the third. Since we're treating this as a whole, this cancels out, and we're left with minus rts squared is equal to wax minus wp to the third. So as you can see now, it's starting to get easier. We start to see this as a whole, and we're getting closer to that t being by itself. I'll just erase some of this work over here to make it bigger. So if we just move this up, minus rts squared is equal to wax minus wp to the third. From this step, that's it. All we have to do is apply it again. The same thing. To get t by itself, we see that negative r times s squared, we'll have to bring that down and divide it in order to just get t by itself. So negative r times s squared, negative r times s squared. Negative r and negative r cancel out, s squared and s squared cancel out, and this moves over, and t is then just equal to wax minus wp to the third all over r, negative r times s squared. And that is how we get t.